All right. Good morning, everybody. Thank you for joining us again for this week's session of the Monsoon Seminar Series. Today, we are joined by Professor Anil K Gupta from the Indian Institute of Technology in Kharagpur. And so without further ado, the housekeeping rules are as usual. We would like you to type your questions into the chat so that at the end of Dr. Gupta's talk, we can kind of call on you to either read out your question or we will just go ahead and read your question for you. Please remember, if you want to receive announcements or like copies of the video recordings through the cloud, just send myself an email or one of the other hosts an email who are Peter Clift or Louis Joson. So again, welcome. And we'll let Dr. Gupta tell us a little bit about the monsoon and South Asian societies. So thank you.
Thank you, Dara. And I thank Peter for inviting me to deliver a talk in this monsoon series, which is a topic of my current research interest. So I'm going to speak on monsoon variability and its impact on South Asian societies during the late Quaternary time slice, which is in fact of societal relevance. So if you look at this climate timeline, the early momentum to climate research was given by mainly by physicists and mathematicians, and it was Joseph Fourier who actually discovered the greenhouse effect. And he actually analyzed the effect of these greenhouse gases in glass greenhouses, and his research was carried on by Tyndall and Arrhenius. But geologists came into fray only with James Hutton's hypothesis or principle of uniformitarianism, where he found glacier deposits in areas there is no glaciation at present, or there are no glaciers in present. And but systematic study by geologists to understand past climate variability was initiated by Cesare Emiliani, who worked with Harold Urey, and he systematically analyzed stable isotopes in carbonate shells of foraminifera and try to reconstruct the history of past climate. And of course, we have numerous other organizations which are involved in understanding the weather and climate variability across the world. Now, this is Cleaver map, which has 13 hotspots or switch and choke points, and monsoon is one of them, in fact. It has both regional as well as global impact on climate. And being a system that drives economy of a very densely populated region of Asia, this is of greater interest to the monsoon workers. Now, if you look at the past climate variability, there are both marine proxies as well as continental proxies. And this seminar series has several presentations by both marine as well as continental workers. And among marine deposits, the ocean drilling program has played very vital role. In fact, it has provided one of the best undisturbed sediment cores to climate workers, where they have sliced cores at intervals of their interest, producing some of the best records from all across the world. And among marine proxies, foraminifera, both planktic as well as benthic, have been analyzed in more detail as compared to other proxies from the marine sediments. And Globigerina boloides, for example, has been used as an upwelling indicator, and Globorotalia menardi as a thermocline species. And also, we have also used benthic foraminifera to learn about the nutrient fluxes as well as oxygen levels of the deeper sea. Whereas In marine record, we have some of the best sediment cores provided by Ocean Drilling Program. On land, we have speleothem, which have been analyzed and producing some of the best records of climate variability in the past, both from China as well as India. Lakes are also quite sensitive to climate variability, and we have recently initiated a major program on lake studies. So isotopic and element ratios, as well as grain size for energy models have been used in retrieving information of climate response of lake during the past few thousand years. And of course, we have ice cores and tree rings, which are also being used in understanding the past climate. Some of the best high resolution records of climate have come from the polar regions. In fact, it was the North Atlantic and Greenland ice that have provided the best ice cores, in fact. And we have gone to generate record of changes in the northern pole up to 120,000 or 200,000 years, and then later on from Vostok in southern pole. From tropics, we have good data from some of the ice cores from Tibet, like Gulia, Dunde, and Dasapo. And of course, speleothem and lake records from China and India have also been analyzed, and we have produced some of the best high resolution records of climate variability. So these are some of the records which have been used as a model to understand the climate variability in other parts of the world. And major late quaternary climatic events which are of great interest to climate workers are like Heinrich events, Dansgaard, Oeschger ice cycles, Bond events, all have been reported from the Atlantic. And then we have last glacial maximum, younger dryas, early Holocene climatic optimum, 4.2 K event, then Roman Van period, medieval climate anomaly, as well as the little ice age. So all these events have been of great interest to the climate workers because of their impact on human societies all across the world. When we analyze any proxy record, the dating is very important. In fact, in order to properly put these events in chronological order, it is necessary to have good dates, in fact. And for carbonate, or for charcoal, we use AMSC14 dating, whereas for speleothems, we have used uranium, thorium series dating. Of course, ice cores have layer counting, and warps also have warp counting. So with that background, we come to the tropics. In fact, tropics are marked by a very important monsoon system, which includes African, Indian, or South Asian, as well as East Asian monsoon system. And we have Australasian, which also impact a small region, which includes northern part of Australia and Indonesian region. And this is the region which is also known as green pool, where it houses major source of moisture, major river systems, forests. And this is also the most densely populated region in the world. So this is a reason where the climate workers have focused to understand how the climate has behaved and how human societies have evolved with time. So our focus is on the South Asian monsoon system or Indian monsoon system. As we all know, the Indian monsoon is marked by... I'm sorry, there is a background noise. The Indian monsoon system is marked by the seasonal reversals in wind direction. In the summertime, we have southwest monsoon winds, which carry moisture from the Arabian Sea and the Bengal, drop over the Indian land mass. And as the monsoon intensifies, it follows the ITCZ, which is pushed to the north during the summertime. And during winter time, the winds reverse from northeast to southwest, and also the intertropical convergence zone is pushed to the south of the equator. Now, it is not only the change in the wind direction, but also the surface ocean response to the change in wind direction. So surface currents also move accordingly. So we have the different ocean current patterns in the two seasons, and these ocean currents are more stronger during the southwest monsoon season. Now, why the South Asian monsoon is so important? In fact, it is so important because of the socio-economic importance. It controls water budget of Asia. It impacts the vegetation, including agricultural practices, the ecosystem, ocean chemistry that affects the global carbon dioxide budget, and of course the economic well-being of the region, which has almost 2/3 of the world's human population. Now, monsoon or monsoon rains are important to the people of India since ancient times, and this is a shlok in Sanskrit from Valmiki Ramayana, which was written in Sanskrit, and its English translation is, "For 9 months the sky drank the ocean's water, sucking it up through the sun's rays, and now gives birth to a liquid offspring that is the elixir of life." So this was said by Lord Ram explaining the rainy season in the Kishkinda Kand of Valmiki Ramayana. Even there are other Indian texts that mention about the structures which have some relevance to monsoon rainfall. For example, in Rig Veda, we have description of ponds, how to collect water during the rainy season, and then as late as during the 1200 AD around, Raj Tarangi describes lakes, tanks, and water management in the northern part of India. So monsoon has been lifeline to the people of Indian subcontinent. In fact, all the great dynasties in India, right, which are now part of Afghanistan and Pakistan, all these dynasties flourished, in fact, along major perennial river systems, which were mainly fed by the monsoon precipitation. It is lifeline. It has been lifeline to the people of India. It is the lifeline to the people of South Asia. And as you can see from this figure, an intense monsoon may cause widespread floods in different parts of South Asia, including India and Bangladesh. And you can see thousands are rendered homeless during this time. But if you look at the other face of monsoon, if the monsoon fails, then the people rush to fetch even a drop of water for drinking purpose. There is no water for irrigation, and the animals die out. So these droughts and intense or extreme events of monsoon rainfall have occurred in the past, and also they have occurred during the last 100 years. And one of the victims of this drought has been River Saraswati. This is the course we have done some work in this, the channel of River Saraswati. We found a very almost abundant course by this river. And on the basis of OSL dates, we found the river probably dried up around 3,000 years ago. Still, we see that the monsoon and human, intervention are playing havoc to the river systems. You can see such a beautiful river in Kolkata. It is Adi Ganga. The pictures were clicked in 1860, 65, 1880. You can see sufficient water in this river. And this is the current picture, current scenario of the same river, same place. It is full of garbage. There is no water, and the river channel has dried up. So the monsoon decrease, as well as the human intervention, human interference in the natural systems, are leading to such a scenario of river network in India. The modern day monsoon research in India began following the great famines of 1866 and 1871. which during which time Bengal suffered maximum, in fact. And British government that time decided to establish India Meteorological Department in 1875 and made Sir John Elliot as its first Director General of Observations and H.F. Blandford as meteorological reporter. But before that, we have, as I showed earlier, there are certain ancient texts where these people have described the movement of clouds and behavior of monsoon, in the past. So, according to Blandford, who actually for the first time suggested, following the drought, following the famine in 1877, he suggested that the Himalayan snow probably impacts the monsoon strength from season to season. And he suggested thicker the snow, weaker is the monsoon in the following season, and thinner is the snow, stronger is the monsoon in the following season. So this is how the monsoon research began by the Indian Meteorological Department, 1878 onwards. But if you look on geological time scale, Himalayan heights, in fact, play the major role. These act as barriers to stop the effect of mid-westerlies, and that is how the monsoon trough moves northwestward. And it is also believed that the closing of the Indonesian Seaway probably brought changes in monsoon seasonality following its closure in the early Pliocene time. So we have both seasonal, annual, and multi-annual, centennial scales, millennial scale, as well as geological changes in the monsoon and climate behavior. Now, the abrupt changes in the climate were first, as I said earlier, studied in the North Atlantic, which are known as Dansgaard-Oeschger cycles and Heinrich events. And scientists began to find these abrupt changes in the tropics. And it was in the Hulu Cave and Dong caves that we see the similar type of repeated occurrences of ups and downs in the monsoon precipitation. And if you look at these curves from the continent, from the Oman margin, from Pakistan margin, there is an alignment between the North Atlantic and the tropical record. So this shows that there is a teleconnectivity between the two records, and the presence of these millennial scale or centennial scale events are not only found in the North Atlantic, but also in the tropics. We have found similar events which are called as bond events in the Holocene time. The cold intervals of the North Atlantic, which are known as bond events, have their counterparts in the monsoon weakening, the weakening of the monsoon winds, in fact. So we see the repeated occurrences of these weak monsoon wind intervals during the Holocene time. So it is not, people thought that the Holocene interval probably was more stable as compared to the older intervals, but that is not true. During the Holocene time, we see such repeated occurrences of abrupt events. This is the data from the Oman margin, again, the last 1,000 years. And we see a mild increase during the medieval climate anomaly in the monsoon wind strength, which is also the time when the precipitation was higher. And over the last 400 years, we see that the southwest monsoon wind have intensified, except in, during the Maunder minimum and during the 19th century event. When we come to the land, as I said, the speleothems provide some of the best records of climate variability, and in South Asia, the monsoon variability. The delta 18 ratio in speleothems is a function of transport pathways as well as source effects. So how far is the source and what is the isotopic composition of the source surface water? And this is the backtracking of wind trajectory, you can see that during monsoon season, the source is mainly the Arabian Sea and the Bay of Bengal in the northeast Himalayan state of Meghalaya. There's another backtracking of wind trajectories in the Sahia Cave, which is in Uttarakhand, central Himalaya, or I would say northwest Himalaya. But here the source is not only the Arabian Sea, but also from the Central Asian region, in fact. So the source is very important, in fact, to explain the isotope ratio in speleothems. Now, in 2014, we initiated from marine to continent, we initiated a new research program on speleothems. And this is the longest record of speleothem from Meghalaya, from Mamlu Cave, which we produced, that we took it back to 33,000 years. One can see younger Dryas has come out very nicely. And then we have Heinrich event 1. But we do not see the LGM. We thought that during this time the monsoon must have been very weak, which is not true, in fact. And then we have the higher precipitation during the early Holocene climatic optimum. When we overlap the solar insolation, we found a good correlation between the Mamlu cave record and the solar variability or sun activity. Later this year, we have taken the Mamlu cave record back in time to 45,000 years, and we have found all the 4 Heinrich events, 1, 2, 3, 4. Among all these 4 events, you can see that Heinrich event 3 is not as strong as 1, 2, and 4. And this we have linked to the source and distance of the source. Heinrich event 3 is of European origin, whereas 1, 2, and 4 are of Laurentide origin. So farther the source, we have more negative delta 18 values, and nearer or proximal is the source, we have less negative delta 18 value. This is another record from an adjacent cave, Umsingrang from Meghalaya. We thought the record will come out very nicely, but the younger Dryas, though we have the presence of younger Dryas in our record, but it is not very neat, I would say. This is the last 1,000-year record from the Vashikar cave from the northeast Himalaya, that is Meghalaya. And we could see 2 major events which we have related to flood events during the medieval climate anomaly. And during the Little Ice Age, what we see that the trend is more secular. In fact, we do not see such abrupt changes in the precipitation. And following the 17th century, we see the changes are quite abrupt, in fact. And these downward arrows are drought events which have been recorded in IMD archives. Most of these events are aligned with what have been reported in the IMD archives. In 2016, we moved to another proxy that is lake, and our first study was in Ladakh region, that is Somorari Lake, where we found the well-known 4.2K event. We could see that the arid phase began around 4,350 years ago, and that continued quite longer, in fact, as compared to the plains or the Ganga Basin. We also have analyzed lake record from the Ganga Basin. This is the site or record from Lilor Lake, which is very close to Ahichhatra. Ahichhatra is an archaeological site, which is a Mahabharat lake, and unfortunately we lost the top 3,000 years record because the government of that state, Uttar Pradesh, removed the top layer for developmental activity. So we could see only the record, which is older than 3,000 years. And then there were some problems with the coring. We found some mixing in the older interval, but in the younger interval, which is rich in clay, we found the presence of 4.2K event. This, we believe, lasted for a few decades, in fact. And then following this 4.2K event, we see a more moist phase. And on the basis of the isotope values, delta C13 of the organic matter, we could tell that the human activity probably was rampant around 3,700 years, or maybe a little more than that. And the agricultural practices began to dominate, which were like camp plants, mainly the winter crops in the Ganga basin, from this time onward, from 3,700, 3,800 years onwards. This is another lake record from Himachal, Revalsar Lake, and in this lake we find very presence of very nice event during the Roman Van period. The monsoon was quite intense, and this is also believed to be the duration when India's economy was probably at its peak. In fact, this began at around 600 BC and lasted up until 500 AD, in fact. But during MCA, or medieval climate anomaly, we see a moderate change in monsoon precipitation. And then we see from 1600 AD onwards, greater precipitation. In fact, this is almost similar to what we have seen in the marine record, a change in wind strength. In fact, the more stronger southwest monsoon winds during the last 400 years. So as a as a climate worker, and to tell something to the history people and to social scientists, we superimpose these historical records on our monsoon record of precipitation record from the Varshikar Lake, Varshikar cave from Meghalaya. And after examining all the historical events, we found that it was not climate actually that was responsible for the demise or fall of these dynasties in India. In fact, there were more than that. Mostly, we believe these were related to social upheavals or social discontent that actually led to such dynasties and invasions from outside powers. So the main highlights of what we have done in lakes, in speleothem and in marine records, we have classified to different time slices. So during post-Inner dryas to early Holocene climatic optima, we see increased summer precipitation and evidence of rise at Lahuradeva. Lahuradeva is located in the eastern part of Uttar Pradesh in the Ganga basin. And there are reports of rise in this Lahuradeva, which are dated at 12,000 years ago. So humans were growing rice. This probably could be the wild variety of rice, but there was a presence of humans and the cultivation in Lahuradeva. Then around 9,000 years BC, we see the evidence of domestication of both plants and animals in the Indian subcontinent. And the wheat probably began as the monsoon began to weaken. Wheat was cultivated by the farmers along with rice, barley, jujube, and other. And these are all domesticated around that time. And late Holocene time, we see more expansion of wheat and barley farming. These are winter crops in the western part of India and also the Ganga basin. During the 4.2K event, we see which is a major phase, in fact, has been reported by numerous workers. Not only we have reported, but also earlier workers. And here we see lots of displacements, migrations of population from west to east and north to south. And this arid phase led to appearance of numerous freshwater lakes in the Ganga basin. In fact, we have seen several lakes which began to develop around that time. And there was also a shift towards pastoralism, that is expansion of village life around that time. Also, there was increased human activity and agricultural practices in the Ganga basin, which were dominated by camp plants. Then we see the first millennium, intense monsoon expansion of rice cultivation in the Ganga basin. During the medieval climate anomaly, we have wet monsoon marked by a few flood events, which were quite pronounced. In fact, the little ice age, we see a secular trend in the monsoon and probably the lower precipitation. And last millennium, we see recurring of drought and flood events, especially during the last 400 years, in fact. So I looked at some of the archaeological sites, in fact, which have been published by Elchin and Elchin. And I plotted these archaeological sites on a map with river systems. I found most of these sites, archaeological sites, which show presence of humans, in fact, are located in the northwestern part of Indian subcontinent, now, parts of Pakistan and Afghanistan. We began our journey in Bolan Valley, that is in Mehergarh in Bolan Valley. And from there, people migrated to the north and to the east, in fact. This happened in the early Holocene time, that is around 9,000 to 7,000 years ago. And as the monsoon began to weaken, in fact, we see the expansion of these movement of these archaeological sites to the east in the Ganga basin, in fact. These archaeological sites began to appear, say 5,000 years ago. This is Aichhatra, in fact, where we have our lake record. So most of these sites expanded to the east. So that means as the monsoon began to weaken, there was less precipitation, less water supply in the northwestern part as compared to the eastern parts. Whenever the monsoon is weak, the east always receives more rains, in fact, as compared to the western and northwestern part of India. So the monsoon played very important role in the shifting of the population and also their agricultural practices with time. And as this arid phase began, as I said earlier, river Saraswati disappeared. In fact, it dried up. This is an abundant channel of river Saraswati where we did some work, and it is believed that this river probably dried up at around 3,000 years ago on the basis of OSL dates. We have also done some exercise as the monsoon, behavior changed with time. You have both wet and arid phases in the monsoon, and how the rainwater harvesting structures have developed in different parts of India, especially in central India and in western India. So we have, made some schematic. This is our imagination that this is how the rainwater harvesting structures appear 2000 BC, and around 1000 BC it was like this. 50 BC around this, and then in the 950 AD was because the aridity, the monsoon began to weaken, in fact, around that time. So we have identified more lakes, in fact, in parts of eastern India, in parts of West Bengal and Odisha, and in northern India also, and we are going to work on these lake sediments to retrieve more information about the changes in monsoon in the eastern part of India, because eastern part of India has not been examined much as compared to the other sectors of the Ganga basin, in fact. So that is what I will end with this figure. Where Samrat Ashoka or King Ashoka says, I will change. I will no longer be known as the evil Ashoka, but as Ashoka the angel. we all know that when Ashoka changed his heart and mind, then he was instrumental in planting trees all along the roads and different parts of his kingdom, which was ruled by him. And I will stop here with the slide where I acknowledge the help by my students, my collaborators, Hai Chang, Steve Clemens, David Anderson, Bern Wuneman, and then scientists from Wadia Institute, scientists from Inter-University Accelerator Center, New Delhi, and of course, Tara and Peter Cliff for inviting me to deliver this talk. Thank you.
Thank you very much. So we'll allow everyone a moment here to type the questions into the chat, and then we can go forward with that for the Q&A session. So while people are putting their questions into the chat, I have a quick question. So I have a kind of personal interest in the history of textiles and things like cotton evolution, because it's kind of a drought tolerant crop. And I was wondering if in some of the lakes that you have been reviewing and the evidence that you've been reviewing with these early civilizations, especially in the Indus Valley, if you found any evidence in terms of people moving towards, I don't know, different types of, I guess, textiles, or maybe if you found evidence regarding that in some of your lakes. I know this is a bit of a broad question, but I figured I'd ask anyway.
Yeah, the cotton is one of the major crops in India. It has been, in fact, it is not now, but it has been the major crops in India, and it was probably domesticated around the early Holocene time. Mm-hmm. But I have actually never thought in that direction. Only thing is, on the basis of isotopic values, we have tried to see whether it was C3 type of vegetation or C4 type of vegetation or camp plants, but we did not look in these lake sediments, in terms of particular seed or particular crop. But maybe in future we might try to see if. But so far we have not done.
Yeah, I basically what I'm getting on with this is it'd be really interesting to see if there was any like turnover in the types of crops that are utilized with the changing in the monsoon. But again, it's all dependent on, you said, on the resolution and the dating and the chronology. So right. Yeah, it's a lot of work by many people.
We have a plan to go to Lauradeva for taking out some cores, and we have a plan to look at those fossilized rice grains, and if we have some other grains as well, and date them and then see how old are those in fact. So we have a plan to go there, but not cotton, because that was not our interest in fact. So yeah, but we might look at.
Yeah, great. Oh, we just had a series of questions pop up in the chat. Excellent.
No, it was a nice talk, and particularly with the history and climate and from Himalayas to that peninsular part of India, then have a very good synthesis on whole and give the glimpse of whole of this area. And I really enjoyed the talk. And your question was very good, that we should also see about the cotton and about these things. And it is, of course, I think Professor Gupta and his team will maybe in the future may also like to go in such studies also.
Yeah,
Thank you so much for having such a nice lecture.
Thank you.
Thank you, sir. It was nice give us a refreshing our memories. Thank you, sir.
So I have a question from Prasenjit, how to, this is very difficult exercise to disentangle southwest versus northeast. We know when the northeast monsoon was stronger, when the southwest monsoon was stronger. But on the basis of that information, we see that in a particular area where at present the southwest monsoon controls the precipitation change, we believe that that the southwest monsoon was the dominant controlling source of moisture in that area. But it is not possible to tell that whether this moisture is from, except doing some ice cores. In fact, in ice cores we can surely find whether it is western disturbance source or it is. But lake sediments, we have not been able to do that. You have to unmute, Tara. You have to unmute your mic.
Thanks. So there was another question about from Sana. Did you want to read out your question? What they're asking
is there any signatures of northeast monsoon in the Indian records during younger dryas and Heinrich events?
Yes, winter precipitation.
Yeah, my same answer. In fact, it's very difficult to tell, because in the northeast Himalaya, like Meghalaya, we do not have much western disturbances or winter moisture source. In fact, most of this winter moisture source comes up to the central part of Himalaya, say Uttarakhand, Himachal. Yeah, we do see in winter time we have lots of moisture coming from the Central Asian region, brought by mid-westerlies, in fact. But Ganga Basin also, these crop patterns, for example, the domestication of wheat and barley and millet, these are basically, these began their journey as the southwest monsoon became weaker, in fact, and we have winter rains. So that winter rains intensification probably led to more winter crops in the Ganga Basin as well in the western part of India, including Rajasthan, Madhya Pradesh, and Maharashtra, maybe.
Okay, we have a hand raised. Jeet Majumdar, would you like to ask your question? Jeet, are you there?
Hello.
Hi.
I think
there is one by Sudeep. There is one question that the monsoon, yes, the monsoon was weak during that time, 1300 to 1700, because this was the transition from the medieval climate anomaly to Little Ice Age. And as we could see, Little Ice Age, the precipitation trend shows more secular trend, and it was a weaker monsoon, in fact, during that time. And we believe probably the cold intervals, the southwest monsoon weakens, which is a general perception, in fact. And during Maunder minimum, which is a part of, around 1700 AD, the monsoon was weakest during the Maunder minimum. So this was also the time when the sun activity was at its nadir, in fact, least. And it is believed that the sun activity probably triggered that change during the Maunder minimum in monsoon and other climate systems.
Okay.
Rajesh Agnihotri, I have a question about how you identify CAM vegetation. We have done on the basis of isotope values of organic matter. We actually analyze what is stable isotope, and we know what is the range of C3, what is the range of C4, and what is the range of CAM plant. So on the basis of that only, we identified that it was mainly the CAM type vegetation that was prevalent in a particular time in the Ganga Basin.
Let's get to Jeet Majumdar's question. He has his hand raised in the audience, virtual audience here. So Jeet, can you please ask your question?
There is one more in floodplain.
I think it was
Yes, Jeet, please
due
continue.
to some software inconsistencies. It was by mistake because of the software, I guess.
I understand. Okay, all right, thank you.
Then Rajiv Sinha has a question. What are your thoughts on picking these signals in the paleo record? We are analyzing lakes only to see a transition from the fluvial system to lacustrine system. When did it happen and how the ecology? Now we are also focusing our work to study micro mollusk, very small size mollusk, which we are observing in these lakes. In fact, in especially lakes in West Bengal have lots of small gastropods and other mollusks, in fact. So we are trying to analyze their isotope values and also their population analysis that might tell something about the riverine versus fluvial versus lacustrine system in the past.
Okay, great. If anybody has any other questions, please type them in here quickly. We've been doing a lovely rapid fire Q&A here. I like it. Yeah, give everybody a moment. Thank you, Rajesh, for answering part of my question. I see in the chat that you noted a little bit about cotton. Thank you.
You know, we as geologists, we owe our responsibility not only to help the archaeologists, to social workers, to economists, and of course climate workers. We have lots of role to play in all these fields, in fact, and it is just a question of reorienting your focus. That's all, and then you can retrieve lots of information about whether it is socio-economic or whether it is related to ecology or agricultural practices or human activity in a particular area.
Yeah, exactly. Clues from the past are excellent for helping make interpretations for the future. So we have one more question here in the chat. So from Sudeep, asking what would be the next part of research to understand the Indian monsoon and is lacking now for understanding the Indian summer monsoon? That's a big question. So I think maybe it's more of what maybe what you think your opinion might be on this question or topic.
Yeah, my answer is that the lakes have not been analyzed in full, in fact, everywhere, whether it is not only in Asia or South Asia, but also in other parts of the world. And lakes are very important, in fact, to tell, because their response to the ambient climate change is more rapid or more quick than as compared to the oceans, in fact, where we get information directly, in fact. So I would suggest the last 2000 years or 2500 years is very important, in fact, to study the changes in these lakes. And if somebody can do it post 4.2K event, because that is the time when most of these lakes appeared, in fact. So that will be the best time slice to understand whether the arid phase really led to the, because we see lots of lakes that appeared probably post 4.2K arid event, where rivers abandoned their courses and these became oxbow lakes, in fact, which are now freshwater lakes.
Great, thank you. So I think that we've had enough questions for now and we can let you off the hook. So again, let's thank Professor Gupta here for his lovely talk and kind of producing all of these very interesting, I guess, topics that we can think on for the future. And again, I think highlighting kind of this role and responsibility I think many of us scientists have with sharing our information with not just other scientists, but with our communities. I'm a big fan of that. And so again, hands together. And so before all of you run away, please remember that we have one more session of our monsoon seminar series before we kind of take a, for those of us in the Northern Hemisphere, a bit of a winter holiday break until about mid-January. So please join us next week for Schedule A, where Jerome Gronveld, again, Schedule A, and we'll send out announcements for that. So again, thank you very much for attending, and thank you so much for your talk, Professor Gupta.
Thank you, Tara.
Thank you.
See you.
All right.
Bye.
Bye, everybody. Thank you.